Hello and welcome to the Linear Equations Benchmark Review. So we're just going to basically go through examples that show you that are very similar to the questions you'll be seeing on the benchmark, and it all has to do with solving equations. So here's our first example, just a basic two-step equation. So remember, when we're solving, we follow the orders of operations backwards. So we have to get rid of our addition and subtraction. So in this case, we have to plus 5 to both sides. So we are left with 3x equals 27. And whenever there's no sign in between there, it's just multiplication, and the opposite of multiplication is division. So x should equal 9. Okay, and also remember we can always check our answers by plugging x back into the equation. So if I were to do 3 times 9 minus 5, I get 27 minus 5, which gives me my 22. So I got the right answer. So this is one of the very basic ones you'll be seeing. Next example, very similar. Still a two-step equation, but now my order of the variable and number is different. So again, I have a positive 15. So stop and think, how would you get rid of a positive 15? A negative 15. So you would minus 15, subtract 15 on both sides. You are left with negative 2k equals 90. And then you would divide by negative 2 on both sides. Because remember, there's always multiplication in between the variable. So k equals negative 45. And again, remember you can always go back and substitute it into your equation to see if you got the correct answer. Alright, I want you to stop the video now and see if you could figure out what to do in this problem. We're thinking opposite operations to undo when we're solving. Alright, I hope you got a chance to try this one, and I hope this is how it went. You gotta get rid of a negative 7, so you're gonna add 7 to both sides. Cancels out. M divide 4 equals negative 12. And to get rid of division, we need to use the opposite operation, which is multiplication. So we're going to multiply by 4 on both sides. M should equal negative 48. Hopefully that's the answer you got. All right, so far we've been doing some pretty basic ones. Move on to the next one. All right, so we're going to move on to the next one. We had a little malfunction with the smartboard, but so this one looks a little bit more complex, but again, whenever we're solving equations, our first step should always be to check, when can we combine our like terms? So in this case, I have a 5p, a negative 2p, and a negative p. So 5p minus 2p is 3p. Subtract another p. I'm left with 2p. And then I notice that I have a positive 3 and a negative 6 to combine. So I'm left with 2p, subtract 3 equals 40. And now we're back to the same equation, type of equation that we started with. So if you can finish this, pause the video. Right, so hopefully you just did the simple two-step part. Add 3 to both sides. 2p equals 43. And divide by 2. So p is going to equal 43 halves. Again, you could convert that into a decimal in your calculator if you chose to. I like to leave them as fractions because I don't have a calculator around right now. Next example, why don't you see if you can pause the video and try this. Remember, parentheses always mean to distribute. Right, so the one thing that's funny about this one is we don't have to really distribute a number per se. Whenever there's nothing here, it's going to be a 1. So all we needed to do is distribute a negative 1 to the r and the positive 3. So we end up with negative 1r, subtract 3. So the sign switched. And then we have two like terms we see that we can combine. So we're left with negative r plus 1 equals 23. Subtract 1 from both sides, so negative r equals 22. And we never want to leave our answer with a negative r. So how do we get rid of that negative? We divide by negative 1 on both sides, and ultimately all it does is change the sign of my answer. So r should equal negative 22. Okay, now we come to a problem that has a variable on both sides. Again, we're still going to need to combine our like terms. So why don't you pause the video and see if you can solve this, and after that you may check your work. Okay, hope you got a chance to try this one. I like to move the smaller variable over, so I have a 2x and a 4x. So I'm going to subtract 2x from this side, just like I would subtract 4 if there were a positive 4. They cancel out, so I'm going to subtract 2x from this side. Left with negative 5 equals 4 minus 2x is 2x. Subtract 11. And since all my variables are on the right-hand side, I'm going to want to move my numbers to the left-hand side. So I'm going to add 11 to get rid of a negative 11. That cancels. So I have 6 equals 2x. Divide by 2. X is going to equal 3. Next example. This one may have been one of the ones on the benchmark thing. I don't know what to do. So if we're looking at this, the funny thing about this problem is there's an x on the bottom. So how do we get rid of a division of x? Same way we get rid of the division by a number. We're going to multiply by x on both sides, because what we do to one side, have to do to the other. The x is no longer divided over here, so I'm left with 6 equals 12 multiplied by x. And next to x, I need to get rid of the multiplication by 12, so I'm going to use the opposite operation, which is division. X is going to equal 6/12, or in other words, 1/2. So this may be one of the ones you got stuck on the benchmark, or maybe this one. So I want you to pause it and see what you think you would do for this one. Right, so you're noticing that we have variables on the bottom, division. We don't like that. This is one of the rare cases that you can cross multiply because they're both set up like a proportion. So if I cross multiply, I have to remember to put parentheses around this. So I'm left with 4 times x plus 2 equals 3x times 6, which will give me 18x. And I don't like parentheses, so I'm going to distribute that 4. So 4x plus 8 equals 18x. Variables on both sides, so see if you can finish this one out. So when we remember we have variables on both sides, we need to get them all to one side. So I'm going to subtract 4x, and I have 8 equals 14x. And I'm going to divide by 14. And so x equals 8 over 14. You can always set that up into a decimal if you'd like, or it's the same as 4 over 7. So again, this is one of the few cases that you can cross multiply to solve because it's a proportion. All right, and we're to the last type of example. So I'm going to just give you a quick explanation and I want you to try it. This says solve for y in terms of x. So they mean at the end your equation should read y equals something of x. So we need to solve for y. Think of 2x like a number in all the other equations. We don't need to solve for x, so we just keep the 2x together. All right, and you're not going to get a number answer for this one. So I want you to pause the video and see what you get, and then check your answer. So I hope that you thought, well, here's my y, and I have a multiplication by a negative 4, and I have this positive 2x next to the y. I'm going to take care of my addition, which is really the positive 2x. So I'm going to subtract 2x from that side. And again, what I do to the one side, I have to do to the other. So I'm going to subtract 2x. Left with 4y equals 12, subtract 2x. Now I cannot combine 12 and 2x because this one's a number and the other one, 2x, is a variable. Now I'm really close to having y by itself, but I still have a negative 4 multiplication. The opposite is to divide by negative 4. So I'm left with y equals 12 minus 2x divided by negative 4. So there's a better way to write our answer though. We can simplify this. So each piece you're going to do 12 divide negative 4, which gives you negative 3. And negative 2 divide negative 4 is going to turn into a positive, and 2/4 is the same thing as 1/2 x. So there is your answer. If you have any further questions, you may rewind the video and just repeat these problems. So I suggest you go back, pause it, see if you can do it without seeing the answer, and you should be ready to take the benchmark soon.